Now let us solve some numericals based on electric potential. Now let us calculate or determine the electric potential at the surface of a gold nucleus, and whose radius is given 6.6 Fermi, 6.6 into 10 to the minus 15 meter, and whose atomic number is 79. And we can consider the nucleus as a point charge. So the formula for potential due to a point charge is applicable. So here what is the charge? Charge equal to, charge equal to NE, where N is the number of charges or number of electrons. Here number of protons in the nucleus, number of protons is Z. So we can write Q is equal to Z into E. Z is here 79, and charge of the electron or proton is the charge of the proton plus 1.6 into 10 to the minus 19 coulomb. Now for point charge, V equal to 1 by 4 pi epsilon naught Q by R, and value of 1 by 4 pi epsilon naught is 9 into 10 to the 9, and charge is 79 into 1.6 into 10 to the minus 19 divided by the radius of the nucleus, that is 6.6 into 10 to the minus 15. So after calculation you will get 1.67 into 10 to the power 7 volt. The SI unit, because all are expressed in SI unit. This is in meter, this is in coulomb. So we have got the unit volt. So this is the potential due to at the surface of a gold nucleus. Now let us solve the second question. Now 2 point charges Q1 and Q2 are given. Q1 equal to 3 into 10 to the minus 8 coulomb, Q2 equal to minus 2 into 10 to the minus 8 coulomb. They are separated by a distance of 15 centimeter, that is 0.15 meter. And we have to find a point on the line joining the two charges at which the net potential is 0. That means, the electric potential obey the principle of superposition. So to find the point at which the net electric potential is 0, I can write V1 plus V2 equal to 0. V1 is the potential due to Q1, V2 is the potential due to Q2. Now let the point P is at a distance x from the charge Q1. So the distance of point P from the charge Q2 is 0.15 minus x. Then potential due to charge Q1 is 1 by 4 pi epsilon naught Q1 by x. Due to charge Q2 is 1 by 4 pi epsilon naught Q2 by 0.15 minus x. And that sum will be equal to 0 as per the question. So now let us put the values. 1 by 4 pi epsilon naught, 9 into 10 to the power 9. This is 3 into 10 to the minus 8 divided by x minus, this charge is negative given, so 2 into 10 to the minus 8 by 0.15 minus 8, that is equal to 0. So these are constants, this will be cancelled out, so that 3 by x minus 2 by 0.15 minus x, that is equal to 0. So after solving, you will get x equal to 0.09 meter, that is 9 centimeter. So at a point at a distance of 9 centimeter from the charge Q1, the net potential is 0. So in this question, there may be another possibility. The point P may lie outside the line joining the two charges. It may lie outside on the extended line AP. That is the extended line AP, the point P lies. Similarly, as before, let the point P is at a distance x from the charge Q1, and distance between charges, this is Q1, this is Q2, is 0.15 meter, that is 15 centimeter. So the distance of charge Q2 from P is x minus 0.15 meter. So in a similar way, again you will apply this one, V1 plus V2 is equal to 0. So V1 will be 1 by 4 pi epsilon naught Q1, that is Q1 by x minus, or this plus Q2 by x minus 0.15, that is equal to 0. Now put the values. 9 into 10 to the power 9. Q1 is once again 3 into 10 to the power minus 8 divided by x. This is minus 2 into 10 to the minus 8 divided by x minus 0.15, that is equal to 0. In the similar way as before, 3 by x minus 2 by x minus 0.15, that is equal to 0. After solving, you will get x equal to 0.45 meter, that is equal to 45 centimeter. So two cases are there. In the first case, this point is inside the line along joining the two charges. That point lies outside the line joining the two charges. Now, question number 3. Let us calculate the electric potential due to a system of 4 point charges located at the vertices of a square of side root 2 meter. The length of each side of the square is root 2 meter. 4 point charges are located. Minus 60 microcoulomb, 20 microcoulomb, minus 50 microcoulomb, 100 microcoulomb. So this is a system of 4 charges. So we can calculate like that. 1 by 4 pi epsilon naught Q1 by R, because we have to find the potential at the center of the square. So the distance, all the distances are same from each charge. Q1 by R, Q2 by R, plus Q3 by R, plus Q4 by R. Or 1 by 4 pi epsilon naught Q1 plus Q2 plus Q3 plus Q4 divided by. That is equal to, now what is R? So now length of each side of the square is root 2 meter. So diagonal of the square is, that is root 2 square plus root 2 square root over, that means that is 2 meter. So R is equal to d by 2, that is half of the diagonal, that is 1 meter. So 1 by 4 pi epsilon value is 9 into 10 to the power 9. Just put the values now. R is here 1. So sum of the 4 charges, that is minus 60 microcoulomb plus 20 microcoulomb plus minus 50 microcoulomb plus 100 microcoulomb. So all total, if you add, you will get 10 microcoulomb. So 9 into 10 to the power 9 into 10 into 10 to the power minus 6. Microcoulomb in minus 6, so that is equal to how much? 9, 10, 4. 9 into 10 to the power 4 volt. Now, question number 4. Let us take an electric dipole whose dipole moment is 4 into 10 to the power minus 9 coulomb meter, and separation between the two charges is not required, and we have to find the electric potential at a distance 0.3 meter from the center of the dipole. So you know that point may lie on the axial line, that may lie on the equatorial line, that may lie on any other point. In the first bit, it is given to find the potential due to the dipole at a distance 0.3 meter from the center of the dipole on the axial line. And the formula for potential due to dipole on the axial line is 1 by 4 pi epsilon P by R square. Here P is the dipole moment. So just putting the values 1 by 4 pi epsilon 9 into 10 to the power 9, dipole moment given 4 into 10 to the power minus 9, by distance is 0.3 square. After solving, you will get 400 volt. If the point lies on the equatorial line, you know electric potential at a point on the equatorial line is 0. So potential on the equatorial line is 0. In the third bit, it is given the point lies on the line which makes an angle of 60 degree with the dipole axis. Suppose this is the dipole, it is given, this is minus q and plus q, this is the dipole axis, and now this is the point which makes an angle of 60 degrees. So the formula will be 1 by 4 pi epsilon t cos theta y square. Now put the values 1 by 4 pi epsilon 9 into 10 to the 9, p is 4 into 10 to the minus 9, and here theta is 60 degree, cos 60 by 0.3 square, so 200 volt. This is the question, and I will discuss a conceptual question. Now, 2 point charges minus q and plus q, they are located on the z axis. The coordinates are 0 0 minus a, this is 0 0 plus a, and it is given what is the amount of work done in moving the charge from point P to point Q on the x-axis. Point P coordinate is 700, point Q coordinates are minus 300. That means these 2 points lie on the x-axis. And you may say that one charge is minus Q, other is plus Q. So you may say it is an electric dipole because it consists of two equivalent online charges separated by small distance. And here this is the dipole axis, the z axis is the dipole axis, x axis is the equatorial line, you may say, because it is perpendicular to that and also passing through the center of the dipole. They are at equal distance from this point. So this may be the center of the dipole. Let me mark it O. O is the center of the dipole. So this is the equatorial line. And you know, on the equatorial line, the electric potential is 0 at each and every point. So as the here potential 0, here also 0. No potential difference. As there is no potential difference, no work is done to move the charge from one point to another. So the work done in moving the charge from point P to point Q